Yes, it's
I
recording.
think started recording. Fine. Thank you. Okay. Uh, Students, come back to the electromagnetic theory. In this electromagnetic theory, what are the topics to be covered? Don't think that this is a simple +1 and a +2 physics. Apart from this, you can see that the questions have asked from uh, the basics of the BSc degree physics also. Okay. In this subject, in this topic, I will cover all those +1 and a +2 topics, and also the topics from the BSc degree syllabus also. Okay. Here, the electromagnetic theory means here we have to study the electrostatics. First, I am giving an outline. What are the topics to be covered in the electromagnetic theory, so that you can score the 8 to 12 marks in the session. Okay. Electrostatics plus magnetostatics. Then electric field in matter, electric fields in matter plus magnetic fields in matter. Actually, you can see the direct questions asked in the several years from the different direct questions from electric field in matter and also in the magnetic field in matter. Need to know, you just need to know the equations only. Fine. And next, there is electrodynamics. In this electrodynamics, we have to study the Maxwell's equations and electromagnetic waves. While studying the Maxwell's equation, you will come to know the displacement currents. These are the broad area that we will cover in the um, electromagnetic theory paper. Fine. If you go again inside, you will see some subtopics like uh, in electrostatics. That is, today we start the uh, Coulomb force, electric field, Gauss's law. In 2015, they have asked one questions from the Gauss's law. That is to find out the electric field due to a hemisphere. Then some options were given, and that comes in the area of the application of the Gauss's law. Fine. Okay. Uh, while teaching on each topics, I will give you the more information. Fine. Don't worry. These are not that much difficult. We will cover all these topics, and we will do a large number of problems also. Fine. Now, let us go to the first one, that is electrostatics. Electrostatics. Fine. Then what are the books to be uh, uh, followed? Actually, you can read if you are really working hard. I think most of you are working hard. Then you start your reading on NCERT textbook. For this current topic, you can read the NCERT part 2. Start solving the problems from the NCERT textbook, and then you can read the Electrodynamics by David J. Griffith. Electrodynamics by David J. Griffith. Okay. And if you go through the previous year question paper, I have seen few questions they have directly asked from the fundamentals of physics Resnick-Halliday. Direct questions they have asked using the numeric. What are the problems? So a few problems given in the textbook, they copied and asked in the some of the previous year question paper. That is fundamentals of physics. The book name, author name is Resnick Halliday Walker. Okay, and one more book is there if you are interested. Suppose if you don't know some concept, then you can read, you can refer these books, and if your time permits, please try to do the problems also from this textbook. Okay, here I follow all these books, and one more book is there, that is a concept of physics, H.C. Verma. H.C. Verma. His lectures are famous in the YouTube. You can also watch that one also. If any topic is, if you want to know more about any topic. There are two volumes, volume 1 and volume 2 in the present section that contains the volume 2. Fine. Okay. Now let us come back to the electrostatics. First, I delete these things. And there are some YouTube videos given by me on most of these topics. If you are interested, we will give the link also. Fine. Now let us go to the electrostatics. Electrostatics means this is a study about the charges at rest. Charges at rest. Study of the charges at rest. The opposite word of the electrostatics is the electrodynamics. Electrodynamics is the charges in motion. Okay. The properties of the charges or the behavior of the charges is entirely different if they are at rest and if they are at motion. Okay, fine. Now we will talk about the different consequence or the different behavior expressed by the charges when it is at rest. Fine. Here the first we will start the Coulomb's law, because you know all the basics. Straight away I am going to the our major topics. Coulomb's law. Coulomb's law is nothing but that is the force of attraction repulsion between the two charges. That is the Coulomb's law. It is a force of attraction and repulsion between the two charges means either it is a charge Q and another charge capital Q. Then if they are separated by a distance R, then the force between them is represented by 1 by 4 pi epsilon 0 QQ divided by R square. Okay, here all of you know this expression. Fine. And this is the magnitude of the equation. Now what is the direction of this equation? Because force is a vector quantity, it has both the direction and the magnitude. Actually the force direction, that if you write, that is F vector 1 by 4 pi epsilon 0 into QQ divided by R square R cap. This is the direction of that Coulomb force. Actually here this charge Q is the, we call this is as a source charge. Source charge. And the charge capital Q, this is we call it is a test charge, which means the force experienced by this charge is actually this one. Okay, that is why we are observing where this charge moves when it keeps near to this charge Q. Sometimes if both charges are the positive, then the force will be repulsive. Fine. Actually, I will come to that. That is, the Coulomb force are maybe the repulsive force or maybe the attractive force. And if both charges are same or like, I think we can say if both charges are positive, either positive or negative, there will be the force will be is repulsive. Here, we need to know certain terminology that will be quite useful while solving the problems. That first is this one. If the force is repulsive, we represent like in this arrow. This is the representation of the repulsive force. This is possible if both charges are either positive or negative. Fine. Now, if one of the charges is positive, which means there will be a attractive force. That will be, this arrow represent attractive force. Fine. Now another point, that is here we have used this expression, that is F is equal to 1 by 4 pi epsilon 0 QQ by R square. R is the separation between the two charges. Here the epsilon 0, this epsilon 0 is called the permittivity of the free space. Permittivity of the free space. Actually, this value of the permittivity, that is epsilon 0 is 8.885 into 10 power minus 12 Coulomb square per Newton meter square. Here the Coulomb, this is not the centimeter, this is a Coulomb, that is the unit of the charge. Fine. Now, while solving the problems, we will use this value. Instead of 1 by 4 pi epsilon 0, we will use this value, that is 9 into 10 power 9. We will substitute 9 into 10 power 9 instead of 1 by 4 pi epsilon 0. Fine. And fine. Now, we have written the expression for the force 1 by 4 pi epsilon 0 Q divided by R square. Then here the charge, one was Q, another one was Q, and the separation between the charge is small r. Now, this epsilon 0 means if the charges are in the free space, this is the permittivity of the medium. Epsilon means, suppose if the charges are in the free space or in vacuum, this is expression for the force. Then the same charge, if I keep it in a medium, like in a water or in a beaker, if I keep the same charges, then there is a water is a medium. That is, this is the expression for the force in a vacuum. In a medium, this expression will come 1 by 4 pi epsilon Q divided by R square. Okay, here this epsilon, that is this term, this is a permittivity of the medium. permittivity of the medium. Now, you can see that some simple questions and also the complicated questions have been asked in the previous question papers. And one cannot say the questions will be only asked from this Gauss's theorem and from this electromagnetic waves. Not like that. In the electromagnetic theory, if you study, and we should not use any mark from this topic. That is why you have to be very careful on each small and in each small topic also. Okay, that is he is a permittivity of the medium. Now, there is a relation. There is a relation connecting. That is, you know that relation. I'm not going to explain the origin of this relation. Straight away, I'm writing the relation. That is epsilon 0 divided by epsilon. Epsilon 0 divided by epsilon. That is a permittivity of the free space with respect to permittivity of the medium. Actually, we call this is as a relative permittivity or dielectric constant. We will call this as a ER or K. This is called as a relative permittivity or dielectric constant. One year they asked which of the following is a dielectric medium. They have given mica sheet, copper, and some other options were also given. Dielectric materials are the material. We will come to that one later in the topic electric fields in matter chapter. We will come to that topic also. Okay, the dielectric material is nothing but the insulating material, mica sheet, paper, etc. And whose constant, that is a K, that we call it as a relative permittivity or dielectric constant. Fine. Okay, these are the small points that you have to be remembered just before switching to the problems. And now one more idea that you have to remember, I will share now. That is, in the case of the repulsive force or the representation of the force in the vector notation. That is, if you have the two charges, let me write this is a plus Q1 charge and this is a plus Q2 charge. Both are positive charges. Okay, the separation between this charge, that is R, and now I am expressing the force. I want to find out the force experienced by the charge 2 because of 1. You know that both are the positive charges. Therefore, I am interested to find out the what force is experienced by the charge 2 and in which direction. Therefore, here, if the both charges are positive, I have to use this notation. That is a repulsive force, representation of the repulsive force. Therefore, this is the direction. And if I write that vector quantity, first I write F2. That is the force experienced by the charge 2. Who is exerting this force? Force is exerting by the particle charge 1. This one. Meaning force on Q2 by Q1. The first letter that I write that represented the which charge is experienced the force. The second letter that represents who is exerting the force. In the similar way, if I write the force on the charge Q1, that is repulsive 1, and if I write this is a force experienced by the charge 1, who is exerting this charge, exerting this force, that is our charge 2. Okay, this is this meaning force on charge Q1 by Q2. Fine. Now, hello?
Sir?
Yes.
Sir, a small doubt. Sir,
Yeah.
is it epsilon by epsilon naught or epsilon naught by epsilon?
Which means you are talking about the dielectric constant.
Yes, sir. Yes, yes. The epsilon, the permittivity of the medium will be epsilon naught into epsilon r, right? Then it will be reciprocal. Epsilon by epsilon naught, sir.
Yeah. Okay. Here I have written permittivity
Yes.
of the medium is yes, epsilon r is equal to epsilon by epsilon 0.
Yes, sir. Yes.
Yes. Actually, I'm sorry. Thank you for the.
Okay, sir. It's okay, sir.
Yeah. Okay, please this one. Fine. Yes, fine. Now, if one of the charge is negative, then no problem. That is minus q1, and this is plus q2. If I want to draw the vector diagram or the force on the force experienced by the each charge, then here that is force experienced by the charge 2, that is because these are the opposite charges, which should be attractive, that come closer, and here therefore I can draw the picture, the diagram, the force direction towards q1. That is, this is a force experienced by the charge 2 because of the 1. And also, if I want to draw the force experienced by charge q1, that should be this one. Here this is a force experienced by charge 1 due to 2. Okay, now let us move to the problems that I have already given. I think, did you get the few problems I have sent? Students, anybody, did you get the set of few problems, 10 problems I have sent?
No, sir.
Oh, okay, fine. Okay, fine. These are the problems that we will solve today. And now let us move to the first problem. That is the problem 1 that I will read. Can you visible these letters?
Yes, sir.
Is it readable? Okay, no problem. I have the problems in the bigger size. That is a lot of things we will discuss while doing the problems also, because this is the theoretical part is we cannot explain everything, but most of the new points or new idea that you will come across while we will solving the problems. Fine. I think now it will be much more clear for. Okay, actually our plan is we should not lose any question from the electromagnetic theory. That's why we are starting from the very small topics and we will go to the difficult topics. See, this is the first question. The ratio of the forces between two small spheres with constant charge in air, B, in a medium of dielectric constant K is. I repeat, the ratio of the forces, they're asking about the ratio of certain forces, F by F, between two small spheres. That is, they are telling about a story of small spheres with a constant charge. They have the equal amount of charge, same amount of charge. I write this is a Q and a Q. That is, here Q1 is equal to Q. That is, Q2 is also equal to Q. Fine. And first, they are in the air. Fine. Now let us write the force between them in air, F air. We have the expression 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. This is general form of the Coulomb force. Now here Q1 and Q2 both are same. That is, we have the Q. Therefore, F air I can write 1 by 4 pi epsilon 0. This Q1 and Q2, Q into Q, that is Q square divided by R square. Now, in a medium of dielectric constant, in a medium of dielectric constant, if you keep the same charge system in a medium, that is Q, here also you have Q in a medium whose dielectric constant is K, then I can write the expression for the force. The distance between them is not changed. Whatever the distance is here, the same when we will keep when placed in the medium. That is, I'll write 1 by 4 pi instead of epsilon 0. Here it was epsilon 0. If it is kept in a medium, this is 1 by 4 pi epsilon, and this will be Q square divided by R square. Fine. Now, you can replace this epsilon. Yeah. You can replace this epsilon by using this expression. That is, you know that epsilon is nothing but epsilon 0 K. Then F air you can write F air sorry, this is not F air. Now we kept in a medium. This is in a medium. Therefore, that's why we have replaced this epsilon by epsilon 0 by epsilon, and this will be 1 by in a medium. We have to write 1 by 4 pi instead of epsilon. We have to write epsilon 0 K into Q square divided by R square. Fine. This is asked what's the ratio of the forces between. While asking the ratio, you have to be very careful. Which one is asked first? That is air. That you have to write here, air. Then next they asked in a medium. Then you have to take the ratio like this one. Fine. Because the reverse, if you do the reverse, and the option will be there in the answer. Fine. Now, F air by F medium means here F air you have this expression, simple substitution, that is 1 by 4 pi epsilon 0 Q square divided by R square. Medium, that is 1 by 4 pi epsilon. Instead of epsilon, we have to substitute epsilon 0 K divided by R square. Then this will cancel, 1 by 4 pi epsilon 0, this cancel, this cancel, this cancel. Then you are left with 1 by 1 in the numerator, 1 by 1 by K, that is K. F air divided by F medium, that is equal to K. Here, this is nothing but F equal to K by 1. Therefore, F air is to F medium, that is equal to K is to 1. Fine. That is K is to 1. That is, this one is the answer. Okay. Just you remember the equation and substitute the values. That is required in the ATC examination while doing the problems. Remember the equation and substitute the values, and some direct straight questions also. That's all. I think this is a simple one. It is clear to everybody. Now let us move to the second question. Fine, I make it a bigger size. Actually, the 2-point charges placed at a certain distance r. Now, in the meantime, while doing such a kind of problems, better you start drawing the picture. 2-point charges. That is, let us make Q1 and Q2. Then placed at a certain distance r in air. That is, they kept at a distance r in air and exerts a force F on each other. They exert a force F on each other. This one exert a force on this one, and this one exert a force on this one. That means here the force is exerted by each one is F. Then the distance r dash at which these charges will exert the same force in a medium of dielectric constant K, which means if we keep the same charges, it is this Q1 and Q2, maybe in a beaker where some water or something may be there, okay, whose dielectric constant is K. Then the question is, at what distance, if you keep this charge Q1 and Q2, that distance is represented, that is this distance, that is r prime. Then the distance r dash at which these charges will exert the same force in a medium of dielectric constant K. That is the same force means here we know that the expression for the force F, that is proportional to the product of the charges and inversely proportional to the square of the distance, and also inversely proportional to the permittivity of the medium also. These are all the factors. Here the distance r is changed. Definitely the force will change. But they are telling that to get the same force, that is in a medium F medium, the force is same, then what should be the distance r dash at which these two charges are placed? That is, here we need to find out the distance r dash. Okay, that is, we need to find out r dash. Fine. When kept in the air, this is a case air, this is a case in the medium. When kept in the air, the force between them two is 1 by 4 pi epsilon 0 Q1 Q2. Here charges are same, Q1 Q2 divided by r square. This is in air. When kept in a medium, F medium, this is 1 by 4 pi epsilon into Q1 Q2 divided by, now the separation is r dash square. Okay, but it is given that both forces are same. F air is equal to F medium, that is equal to F. This is nothing but F, and this is also nothing but F. Therefore, you can equate, that is 1 by 4 pi epsilon 0 Q1 Q2 divided by r square is equal to 1 by 4 pi. Here, instead of epsilon, just now we have substituted epsilon 0 into K if dielectric constant is given, and Q1 into Q2 divided by r prime square. Fine. See this one, 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 cancelled. Q1 is 2 cancelled. And here we have 1 by r square is equal to 1 by k r dash square. Now, that is r square is equal to k r prime square. Fine. That is our r prime square is equal to r square by k. That is r prime is equal to r by root k. R by root k is the answer. So this one. Okay, hope application of this equation. There's a Coulomb force in the medium and in air or free space. Now that is very simple and it is very clear to you. Fine. Now let us move to the some other kind of problems that is based on the Coulomb force, that is here. I may use some kind of the properties of the vectors. Okay. Actually, whatever the some new shortcut or ideas that we need to use, that I will explain, and when it comes in the problems, because if we are telling the shortcuts and tricks as a separate class, that is not at all good, and it will take much time. Fine. Now come to this problem and see how this can be solved. It is 4 charges QA, QB. See, QA is equal to 2 microcoulomb, QB is equal to minus 5 microcoulomb, QC is equal to 2 microcoulomb. See, here QA is 2 microcoulomb, QC is also 2 microcoulomb, QB minus 5 microcoulomb, QD minus 5 microcoulomb. Charges are same, 2 charges are same, are placed at corners of a square ABCD of side 10 centimeter. That is, now we have to draw a square. Fine. That is, believe that this is a square. Fine. The charges that is kept, this is a QA, that is equal to 2 microcoulomb, and this is QB, that is equal to 5 microcoulomb. BC, next to C, that is QC, that is 2 microcoulomb, QD, that is equal to minus 5 microcoulomb. The side of the square, that is given 10 centimeter.
Sir, B is also minus 5.
Yeah, B is also minus 5. Thank you. Yes, fine. It's also minus 5. What is the force on charge of 1 microcoulomb placed at the center of the square? Okay, that is, if you place a charge at the center whose charge is given 1 microcoulomb, what is the net force experienced by this charge? That is a question. Okay. Now, while doing this kind of problems, we need to find out the force experienced by this charge due to the each charge. We have to find out the net force on the charge, the center, because of the charge A, because of the charge B, C, and D. Here, the charge given in the question, that is 1 microcoulomb, is a positive charge. Now, the force experienced by this 1 microcoulomb charge, if I write, that is a sum of the force on the 1 microcoulomb charge, because due to the charge at the position A, plus there is a vector sum of the force. Okay, then the force experienced by the 1 microcoulomb charge due to the charge placed at the point B is FB, and force experienced by the same charge because of the charge placed at the C point, that is FC. These all are the vector sum. The force experienced by this charge because of this one, that is F1T. Here, this is the force experienced by charge 1 due to the charge A, force experienced by charge 1 due to the charge B, and it goes on. Now, if I draw the picture here, that is, you know the vector in mathematics. If you have a vector like A is equal to 5x cap, then you can write this vector as this one, vector A, and vector B, that is 2x cap, then you will write its length a little smaller. Okay, if this magnitude is larger, then the length of that vector will be larger. Fine. Such a method we follow while here while solving this kind of problems also, because our force is a vector quantity, and in the next section we will deal the electric field also, that also a vector quantity. And wherever you deal vector quantity, the same procedure you can apply. Okay, I will come to that later also. Now see, the force experienced by this 1 microcoulomb charge, because of this charge A means both are the positive charges, then this force exerts along the line of the joining the two charges. Our Coulomb force is a force that acting along the line joining of the two charges, which means if this is a charge QA and this is our 1 microcoulomb charge, this one is our 2 microcoulomb charge, then the force of attraction or repulsion that may take place along this direction or this direction. That is a line connecting these two charges. Okay. Therefore, this Coulomb force, that is F is represents Coulomb force. This Coulomb force is a central force. Okay. Always we have to draw the vector diagram, so the vector direction along the line joining of the two charges. Another example of the central force is the gravitational force. For example, Earth and Sun, the force of attraction between this one, that is a gravitational force that we will discuss in the gravitational force chapter, that is in the classical mechanics. You will study that one, that is G M M അല്ലെങ്കിൽ G M1 M2 divided by R square. This force of attraction also takes place along the line joining of the two bodies. These are all the central forces. Okay. While dealing such central forces, you have to draw the vector diagram along the direction of the line joining of the charges. Now, if you draw the vector diagram of that is a force experienced by this charge, that is a repulsive force. I write this is a force experienced by the charge 1 microcoulomb because of the charge A. Now, next I have to draw what is the force experienced by the charge 1 because of the B. That is, this is the line join in these two charges. This is the negative charge and this is a positive charge. For a negative and positive, it should be some kind of like this attractive force I have to draw. That is, what happened is this positive charge move toward this charge. But be careful about the length of the vector that you draw. Okay, here the force that we are writing here, that is proportional to Q1 Q2 divided by R square. The length of the force that depends upon the product of the charges, magnitude of the charges, and inversely proportional to the distance between the charges. Accordingly, you have to draw the length of the your vector. Okay. Now here one Q1 maybe you can take it as 5, Q2 you can take it as 1. Here Q1 and Q2 it is a 5 into 1, that is 5. But in the previous case here it was 2 into 1, that is 2 into 1, that is equal to 2. I have for 2 I have written this length. Then for 5, because the distance between them is same from this origin from this corner to the center, both distance are this distance are same, but only different is the magnitude of the charge. Therefore, I have to draw this one. Okay, this is a force experienced by charge 1 because of the charge kept in the corner B. Similarly, the force experienced by the charge due to the charge kept in the corner D. Then here also minus 5 Coulomb Q1, Q2 is equal to 1 Coulomb, and 1 is the negative, the other one is a positive. Therefore, there will be an attractive force like this one. this means our charge come towards this direction. Be careful, its length should be same as that of this one. Okay, fine. Now, one more force is left. We have drawn this one is left. Force experienced by the charge 1 because of the charge 2. See, this is a 2 microcoulomb, this is a 1 microcoulomb, both are positive charge. The force is repulsive, and this Q1, Q2 for 2, we have drawn this length, and now this and these charges, that is repulsive force, I have to draw in the same length. These and these are the same length. This is the force experienced by the charge 1 microcoulomb because of the charge placed at C. Now it is clear that is this force and this force cancel, this force and this force cancel. Therefore, the net force experienced by the charge placed at the center 1 microcoulomb, that is charge experience, is 0 force. Okay, actually in most of the competitive examination, if vector type, if the quantity that is asked is a vector, then without knowing much information, simply by taking the direction, you can predict the answer. Okay, that you will come to know we will while doing the problems later. Now, therefore, the answer is 0. Fine.
Sir,
Okay.
I think
Yeah. Yeah. Please tell me.
Sir, for FB, no, FB the direction should be inwards, right?
FB
Because
FB
FB and FC, it is
just 1 minute. I will
it
delete
is
the
attractive
marking.
force, no, minus and plus.
FB must be attractive. You are telling about attractive. Yes, I have drawn the attractive force because the charge.
Yes, sir.
Okay. This
But
there is 1 microcoulomb charge goes towards where QB. QB is equal to minus 5 microcoulomb. Is it correct? FB. FB means this is a force experienced to 1 microcoulomb because of the charge placed at the B. Okay, you are confused, or should I explain once again? Hello?
Sir, please to explain once again.
charge is
fine.
negative and positive.
Oh, okay, yeah. Actually, the problem is here students get confused because our Coulomb force F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. Some people, what they will do is, if Q1 is equal to 5 microcoulomb and Q2 is equal to minus 1 microcoulomb, they will substitute this minus here in the expression. Then they will get finally minus 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. If Q1 and Q2 are, one is plus 1, minus 1, another one is a plus 1. While doing these problems, first you have to decide the direction of the force by looking at the sign of the charge. Okay, now I will draw the bigger picture of this one, that is square, and I will explain once again, because this has to be very clear, because in the next session, that is while calculating the electric field, we will come across the same problem. Here you have QA minus 2 microcoulomb. This is QA is equal to minus 2 microcoulomb, and this QB is equal to minus 5 microcoulomb, and the QC, I think -2 microcoulomb. Okay, no, one more than +2 coulomb. Here I have written, okay, fine. This should be +2, and this should be +2, and this should be QD, that should be equal to -5 microcoulomb. Now we are interested to find out the net force on a charge placed here. Fine, this is our QD. This charge is 1 microcoulomb. Okay, I will write here 1 microcoulomb. Fine. Now, as I mentioned, first I want to draw the force for this charge Q because of the charge QA. If I draw that force, both are the positive. This one is positive, this one is positive. The repulsive force. We have to concentrate only on this one. Where this will charge move, this charge will move away. Okay, this one. This is a force on this charge. This force is exerted by the charge placed at A. Now I am writing only one one laterally to avoid the confusion. This is a force experienced by this charge. This force is exerting the charge placed at A. Fine. Now, the force experienced by this charge due to the B. This one is a positive charge. This one is a negative charge. If one is either of the charge is positive or negative, there will be the attractive force. Now, you have to concentrate on what happened to your charge. No need to consider this one, which means don't consider this charge. Where your charge will move. Your charge is this one, and because if it is attractive force, then this move this direction towards the this one, negative charge. And while drawing the length of the arrow, we have to be very careful about the product of the charges. This is a 5 magnitude. This is a 1. Therefore, I have drawn bit lengthy. Now, this is a force on the charge 1 microcoulomb exerted by the charge placed at the point B. Next, we have to draw the force experienced by this charge, central charge, because of the charge C. Now, where our charge will move? To know that, just check about the sign of the charge. This is a 2 microcoulomb plus 2 microcoulomb. This one is a plus 1 microcoulomb. Both are positive. Therefore, that will move. That is a repulsive force. Our charge will move in this direction. And this is a, and be careful, the distance from these and distance from these both are same. Therefore, whatever the length we have drawn here, the same length I have to draw here also. This is FC. Fine. Now, is it okay? Please.
Yes, sir.
Yes, sir. No, it's
Fine,
okay.
fine. Now the last force, the force experienced by the central charge because of this D, that is attractive force, because this one is a positive charge, this one is a negative charge. For attractive, you always write this one. And we have to concentrate on where our charge will go. That is, we have to concentrate on this charge. That is, this one will go this direction. And length should be careful. That is, because for this length and for the same magnitude, -5 microcoulomb, 1 coulomb, we have drawn this length, then the same length we are going to draw here also. This is a force experienced by the central charge because of the charge placed at the point D, FD. Now you see, if you are a person standing here and one fellow is pulling you in this direction, another fellow is pulling you in this direction with the equal magnitude, 10 Newton, 10 Newton, then net force is 0. You will not move in a direction. You will be there, though you are getting 10 Newton from both sides. Therefore, here these and these cancelled. These and these cancelled. If suppose if this charge, that is charge placed at the point B, is 4 microcoulomb, minus 4 microcoulomb, then the situation would be different. That is, here this arrow that you have drawn here, that should not cancel. Maybe slightly the strength of the force will be smaller, and this portion and this portion cancelled, and this already cancelled. The result is that our charge, that is this charge, that it will move towards this QD. Okay. This is the way to solve the force problems. Okay, don't worry. We have slightly different questions based on the Coulomb's force. The fourth problems. Okay. See, this is a quite interesting question, because several competitive examination, you might have seen this one, this type of question. That is 12 equal charges Q, each charge, 12 Q charges are situated at the corners of a regular 12-sided polygon. Okay, that is one polygon is given here. That is 12-sided polygon. One on each numeral of a clock face, which means here we have 12 Q charges placed at each numeral of a clock face. That is, here you have a charge Q, another charge Q. In this way, all places you have a charge Q. Okay. Fine. Next, what is the net force on a test charge Q at the center? Okay. What is the net force on a charge Q kept at the center? If R is the distance from center to the each numeral, that is, if you take any point, this point or this point, that distance is R, that is the same. That is given in the question. Our aim is to find out what is the net force experienced by this charge that is kept at the center. This is very simple. Very simple in the sense, while calculating the force, just you see the direction. That is, the force is proportional to the product of the charges and inversely proportional to the square of the distance. Here, all the charges are identical. Then, suppose first we draw the force on this charge because of this small charge. Okay, suppose if you assume that this is a clock, here 1, 2, 3, 4, 5, 6. Sorry. Let us write in the, it is mentioned that if 1 on the each numeral of a clock face, then we can write this is a 12, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Our aim is to find out the force experienced by the charge Q at the center. What is the net force experienced by the charge capital Q? Can anybody tell? What do we have to do? Just you can do this procedure. That is
0.
Yeah, of course, 0. Because force experienced on the central charge because due to this one, that is this is our Q. Both are the positive charge. This will force between these charge and these will be repulsive. That will be alone in this direction. Because Q1 and Q2, that is Q into Q divided by separation between these two charges, that is constant R square. Maybe you can write this is a F2 force exerted by the charge 2. Similarly, if you draw all the force diagram, suppose the force exerted by the charge placed at the 11 to the charge Q, okay, that will be along the both are the positive charges repulsive force. This is F11. And if you draw this force between the charge placed at this point, that is 6, and this charge, that will be along this direction, because you have to draw the line, and this force is acting along the line joining of the charges. And if you draw all these forces, then that will cancel. This is F6, and now the force exerted by the charge 12 on this charge, that is along this direction, because along the line of sight you have to draw the force. This is the F. Okay, length should be same. This should be F12. For the moment, if you see this F6 and this F12 cancelled. Similarly, these two cancelled, and net effect is that all the forces will be like this, and the cancelled net charge will be 0. Okay, there was one of the interesting question, that is if suppose one of the 12 Qs, that is 1 at 6, is removed. Okay, that is there are 12 charges in the clock, but one charge placed at 6 is removed. There is no charge here. Then what would be the net force on the charge placed at the center? So simple question. Can anybody tell? I repeat the question again. There are 12 charges in the clock, and among these 12 charges, one charge placed at the 6, that is here, this point, is removed. Then what will be the net force experienced by the charge Q?
The net force corresponds to the removed charge into the center charge by R square.
Yes,
1 by 4 pi epsilon.
yes, exactly. Yes, yes. That is, just now we have seen that if one more charge was here, then all the forces will cancel, and the net force on the charge will be 0. Here, if one charge is missing from the this region, this point, then you have all the 11 charges. Then if you draw the force on this charge because of the 12 is opposite to the 6, and this force will be along this direction. This is the force exerted by the 12th charge. But to cancel this force, there is no charge here. Therefore, there is no force in this direction. Then all other force might have cancelled those, but here in this direction you don't have any force. Therefore, this particle will experience, or this charge placed at the center Q will experience a force along this direction. That force F is equal to, very simple, 1 by 4 pi epsilon 0. Q1 is Q, that is, this force is exerted by this charge Q, and Q2 is our capital Q, divided by separation between these two charges, that is R, and this square. Okay, if one of the charge among the 12 at the place of 6 is removed, then the force will be this one. Okay, Now, one thing you can conclude here. Suppose if you are any polygon is given, like here this is 12-sided polygon, that may be hexagon, that may be a square. Okay, then if the number of sides, that is the number of sides, here the number of sides means here we have the 12 side is equal to the number of charges. And also, that is, if the for a n-sided polygon, if the number of sides is equal to the number of charges, and the side of the length of each side, there are two conditions. First condition is this one, and second condition, the length of side length of each side must be same. Then the net force on a charge placed at the center of that n-sided polygon, that will be 0. The net force on any charge placed or kept at the center of that n-sided polygon will be equal to 0. If at any corner, if one charge is removed, means simply you can apply the rule equation by 4 pi epsilon 0 q1 q2 divided by r square. Fine. Now let us move to the next question. That is this time is flying like anything. It's a very simple question. That is see, two small spheres, each having the charge plus q. That means two spheres. Okay, I don't know. Let us read more. Let us proceed. Two spheres each having charge plus q are suspended by insulating threads of length L from a hook. Actually, we have a hook. This is a roof. From the roof, we have a hook here. Then we are suspending two sphere. Okay, two small, each having charge plus q. Okay, fine. Both are having the charge plus q. This arrangement is taken in space where there is no gravitational effect. Fine, we can neglect the gravitational force. Then the angle between the two suspensions and the tension in each will be, once again, then the angle between the two suspension means this is the angle. What is this angle? That is the first question. The angle between the two suspensions and the tension in each. What is the tension? Tension means here in this picture, tension is this one. Okay, suppose if you have a mass m, a block having a mass m suspended like this, tension is always pointed away from the mass. This is the tension. Tension is a force. Actually, this is nothing but a tension means it is nothing but a force. Here we need to find out this tension, that is a force. What is this force and what is the angle? If both charges are plus q and there is no other effect of the gravity. Can you do this one? Actually, I think already 8:20. We have to do a little bit more problems. I move fast. That is here. The charges are both are positive. Therefore, there will be a repulsion between the charge. What will happen is, if there is no gravitational force, then what will happen is, because of the repulsion, this will go this side, repulsive, this will go this side. Okay. Now, this is the point of suspension, this one. Here, this is the point of suspension. Then our one sphere will go this direction because its length is already given. This is the length L already given in the question. It is here, the length is given. And now another bob will move in this direction because both are positively charged sphere, plus and plus Q. I mentioned in the classical mechanics, you will see that tension is always away from the mass. We need to find out the force also. There is a force between these two. Now it is clear that because of the Coulomb repulsive force, the angle between them, theta is equal to 180 degree. Fine. Now, what is the force? F is equal to 1 by 4 pi epsilon 0. Product of the two charges, Q1 is equal to Q, Q2 is equal to Q. That is Q into Q, that is nothing but Q square divided by separation between the charge. This is the separation between the charge. One length is L, another length is L. Therefore, the total length is 2L. Difference, that is 2L whole square. I think no need to solve further because already given in the question, in the option. That is the force is this one, angle is this one. I think the first option is a correct one. See, they are framing a lot of questions based on a single concept also. Okay. Now, I think you will get these questions, and don't worry. Now, please look at the solution only. Now, this is another kind of problem usually seen in the question papers. That is a charge Q. The charge Q means single inverted comma Q is placed at the center of the line joining two exactly equal positive charges Q. That is, we have two charges Q and Q. A charge small q must be placed at the center of the line joining of the two charges. That is, there is a charge q is there, and here the separation between them, let us roughly we can take something like a d. We have to bring and deposit our charge here. That is exactly at the center of the line joining of the two charges, so that the system of the three charges will be in equilibrium. Okay, if this newly given inserted charge is equal to dash. This is another common type problems asked in the from the Coulomb force in the various competitive examination. Now, how we can solve this kind of problems? If any problems you see that the system is in equilibrium, then that means if you consider any charge or any body in the system, then the total force on that particular, it may be the total force on this charge or total force on this charge, that will be zero. That means if a system is in equilibrium, then the total force on any charge will be zero. I think for a system in equilibrium, the net force on any charge will be equal to zero. Here, this point has to be remembered. Anywhere you will see the equilibrium, then that system, whatever you make some perturbation, disturbance to that system, that will not affect the total force on that system will be zero before and after making any perturbation to that system. That is a general rule actually. Now, if I calculate the total force on this charge, that is, for the calculation, I name it as a charge 2. This is as a charge 1. Then the force on the charge 2, total force on Q. Let me write here. Total force on Q, that is 0. That is a non-factor. And what is the total force? What are the charges that is exert force on the Q? First, this charge at the position 1 exert a force on this charge 2. Both are positive charges, therefore this is a repulsive force. This is a force experienced by the charge 1. The charge who is exerting the force, charge 1 is exerting the force. Okay, fine. Now, let me write that is a F21, that force plus. Next, if I bring this charge, small q charge, to this point, at the middle point, then the force, that is, I brought the charge q here, then the force on the this charge q due to this newly brought charge q, that is I write, because both are the, I don't know what is the sign of this charge actually. For the system, if this charge q experiences a force in this towards the right direction, right side, which means if you are applying some force on this body, if you are applying the force on this body, if you are getting this unbalanced force, means this body will move in this direction. But to bring this body into the rest, you have to apply the equivalent amount of force in this direction. That means for a body to be in equilibrium, or the total force on a charge to be in equilibrium, that the body should get a force like this, equal and opposite force. This may be F1, this may be F2, but this F2 should be equal to F1. Okay. Now, for the charge Q to be in equilibrium, they should get a force in this direction. Then only net force on this charge will be 0. That force I will denote as force experienced by the charge 2, because of this force is experienced by the small charge q. That is, this force is exerted by the small charge q on 2. Therefore, we can write this F21 plus this F2q, that is equal to 0. Now, very simple. You can substitute what is the value of F21. Okay, time is almost around 8:30. After solving this problem, we will stop, and I will give you 2-3 minutes for the doubt clearing session. And F21, the force between this charge and this charge, that is 1/4 pi epsilon 0. Actually, here what we will do is, instead of writing 1/4 pi epsilon 0, let me write this is a k, because all the charges are still in the same medium, that is k. K means 1/4 pi epsilon 0. Then charge 2 is q, charge 1 is also q, therefore q1 q2 means k square. Different distance between the charge 2 and 1, that is our this d square, q square by d square, plus next F2q means force between the charge 2, that is k into q. Next charge is q2 is small q, divided by separation between the small charge q and this 2. That is the separation between these two, means here this is the separation, d by 2. D by 2 whole square, that is equal to 0. Now this is very clear. This k cancelled. 1q cancelled. Here d square, and here this d square cancelled. Remember, there is a 1/4 is there. That is q plus small q divided by 1 by 4, that equal to 0, then q is equal to q plus 4q is equal to 0, then 4q is equal to minus q, and it is asked what is the value of q, that is minus q by 4. Minus q by 4 is the answer. This one is the answer. Okay. Actually, one thing you can predict actually without doing this calculation. Suppose if you are not having enough time, you are left with 30 minutes after the 30 seconds, then your examination, your system will shut down. Then exam is going to be finished. Then you can predict the answer. How you can predict the answer without doing this calculation? Simply see here. Question is, if the system third charge is to bring into the middle point, so that the system should be in equilibrium, so that you know the concept, that is the net force on, if you calculate the net force on any of these charge, that must be 0. Then first I calculate the force on this charge due to this one, that is along this direction. Then 2. Then to cancel that force, the direction should be reversed. To get the force in this direction, this charge should be negative. Okay, that negative means you can clearly omit this one. This cannot be the answer. Either this one or this one. That is your luck. Maybe you can put, if you are lucky, if this one is correct, means you will get the mark. In that way also, if you don't know the correct procedure, and if you know a little bit, you can the vector directions and calculating the product of the vectors. And there are some formulas that we will discuss in next class. If you know those tricks, without doing much calculation, you can predict the answer. Okay, thank you very much. We will do the rest of the problems in the next class. Okay, anybody? Anybody has any doubts or anything else, please?
Sir, here the k is equal to 1 by 4 pi epsilon 0 in the last question.
Last question, I think 5th one or 6th one we did. Okay.
For F21, we wrote that k into q square by d square, no? So where the k is equal to 1 by 4 pi epsilon 0.
K is 1 by 4 pi epsilon 0. Yes, exactly.
Okay, all the questions we can write if we
yeah,
have,
instead of
but
1 by, yeah.
No. But if we have medium, then only k will come. No?
Okay, yes. That is good. That is good. Actually, simply I have written, instead of writing this whole term, I simply wrote this is a k. Maybe you can write p or something. Usually that is like writing the k. So dielectric constant also we use k.
Okay, because simply you take a variable.
Yes.
Okay, can you tell me the next step after that step, because I didn't get
actually this is a numerical only, because that I will actually what I have written, this one is that F21 force that we have written, we have 1 instead of 1 by 4 pi epsilon 0 k we have written. Then the force between these two and 1 means this and this, that is q square divided by separation is d square, plus F2 means this force, that is k into charge 1 is q, another charge is small q, that to be determined, by d by 2 whole square equal to 0. I hope up to this you are clear, I think.
Yes, sir.
Fine. Now the right hand side is 0, na? Or if the right hand side is 0 means you can bring this term to this side, that is
okay. Good.
then this and this cancel. Okay. Anybody Okay, if nobody has any doubt, means tomorrow we will next class we'll discuss the electric field, then Gauss's theorem and its application, and then we'll use previous year questions. What are the asked in the each topics? That we will also discuss. And
Yeah, if there is no question, then we can wind up the session.
Yeah.
Isn't it?
yeah, please, anybody ask any question, please.
Rashid sir, can you please stop the record?
Oh, okay, fine. Okay.
Dear students, so we uploaded last